Hi, good afternoon. So we're going to talk today about chapter 10, which is enteral and IV solutions. The good thing about that enteral and IV ways are the fluids can be given to the patient slowly through the IV, which is in the vein or intravenous, and through an electronic pump. The rate of infusion is set electronically. So the IV solutions, there are electrolytes. A saline solution is a solution of sodium chloride in sterile water, and it has 0.9% NaCl solution. So what does that mean? It means that there are 0.9 grams of NaCl for every 100 milliliter of solution. That's normal saline. So if you see something like 5W, D5W or D5/W or 5% DW, it means that it's 5% dextrose solution. So if it said D10W, that's a 10% dextrose solution. If it said D20W, it would be 20% dextrose solution. So it means this D5W means that there are 5 grams of dextrose dissolved in water to make 100 milliliters of solution. These are what the IV things look like, the IV bags. Oops. So if you look at this first one over here, if you look at this one, then you see that there's 5% dextrose and 0.45% sodium chloride. And that means that there are 5 grams of dextrose and 0.45 grams of sodium chloride in each 100 milliliters of that solution. If you look at Ringler's lactate, that's the second one here, 5% dextrose, it means that there are 5 grams for every 100 milliliters. Move this, let me move it back up. Ringer's lactate, or RL, is a solution containing electrolytes, including potassium chloride and calcium chloride. Calculations for infusions. So there's a flow rate. It's going to be in milliliters per hour. The duration of the time for the IV is going to be an hour, and the volume is going to be in milliliters. So it'll be over milliliters per hour is your flow rate. This is the rate at which fluid drips from the IV bag into the IV line. So the units are going to be in drops per minute or GTT per minute. The size of the drops vary because of the size of the rubber tubing. So there are different tubing sizes, and the different tubing sizes tell you how many drops per milliliter of total solution will go into your patient's body. So there is a 10 drip system, which will give 10 drops per milliliter. There is a 12 drip system, which will be 12 drops per milliliter. There's a tubing with 15 drip system, which will be 15 drops per milliliter. And there's one with 20 drops set. So it'll give you 20 drops per milliliter of solution. So if your tubing is small, you'll have more drops per milliliter. If your tubing is larger, then you'll have less drops per milliliter. And each of your equations or orders or situations will tell you which drop set you're using, so you don't need to know those. An IV solution will be labeled with the number of drops that equal to 1 milliliter. So a micro drip set, that's something different. That's something you'll have to know. Maybe you should put that on your conversion chart, because every time you see micro drops, MC, GTT, then if they're talking just about a microdrop, then it's 60 microdrops per milliliter or 60 GTT per milliliter. So they are used to limit the volume of fluid for pediatric patients. The drop factor for any tubing is 60 microdrops per milliliter. So here's an example of an order. The order is IV fluids, dextrose 5% in water for 125 milliliters per hour for 8 hours. So the name of the solution is dextrose 5% in water. The rate of flow is 125 milliliters per hour. The route is an IV. And then the duration is for 8 hours. So when I first started teaching this class, I didn't know that the IV bags had salt in them. I thought it was just water and they just pump your veins in water. And then I found out that that would kill you. So not a good idea. And then I found this little thing. It's pretty cool. This little fish says to the other little fish, I tried fresh water once. Talk about bland. I know you're laughing. I can hear it. So IV rate flow problems, I wrote out a set of directions for you to easily solve these problems. You're first going to find what the equation is asking for and label your answer. Then you're going to underline the numbers that combine to make your like fraction. And these are words that mean divide: into, per, with, for. So that's going to be your unit fraction or your fraction. Then we're going to find the units in the problem to match units in the answer. If the top units are drops, then your first fraction should start with drops on top, because if you have drops in the bottom at any point, then it's not going to, not at any point. If you start with drops at the bottom, you can't get them on top. So if there's a time at the bottom, the first fraction should start with the time on the bottom. So time can be in hours or minutes, but you have to be careful. Because you can convert to whatever you need later. So we're going to set up the rest of your fractions to cancel units until the end units match, and then do the math to complete your problem. Remember, no units is no credit, and that's true in nursing. So you're lucky because we're doing a MyLabs Plus system, and in that system, they give you the units. But if by chance you're watching this video at another time, then they may not. And so units matter, and no units is no credit, or wrong units is no credit, because a milligram is different than a microgram. So your order is normal saline, 1,000 milliliters continuous in an IV for 24 hours. They're just giving you a bunch of information. So remember, what you're looking for is your label for your answer. And this says find the pump setting in milliliters per hour. So if I want to find the pump setting in milliliters per hour, I labeled my answer. Now I'm going to start it with either milliliters on top or hours on bottom. So when I look, I'm going to underline something that will match 1,000 milliliters for 24 hours. So that's one fraction that goes together, and 1,000 goes on top because milliliters is on top of my answer, and 24 hours goes on bottom because hours are on bottom in my answer. Then I look and I say these labels match these labels, so I can do my calculations. So this was the easier one, a one-step one, and I'm just going to say, oh, cool. So 1,000 divided by 24 is 41.667. 41.67. So it's going to be 41.7 milliliters per hour. A patient must receive a tube feeding of Ensure 120 milliliters in 90 minutes. Calculate the rate of flow in milliliters per hour. So when I look, I see milliliters per hour. And that's what I need. So I'm going to underline my things that go together, and this milliliters in 90 minutes. So I'm going to put my milliliters on top, 90 minutes on bottom. And then when I check, my milliliters match, but my hours don't. So I need my minutes to go on top to cancel with my minutes on bottom. And I know that there are 60 minutes in an hour. So when I cancel out my minutes, I cancel out minutes and minutes. And when I end, it'll say milliliters per hour. And I look and I need milliliters per hour, so I know I'm done. If I flipped the milliliters and minutes, then I wouldn't have canceled anything and I'd get some funky solution for my answer. So then I'm going to do 120 times 60 and get 7,200 and 90. So I'm going to do 7,200 divided by 90. And I would get 80, so it'll be 80 milliliters per hour. So a dextrose 5% in water has been infusing at 30 milliliters per hour for 8 hours. How many milliliters have infused? So this asks for milliliters. How many milliliters? So I need my answer to be in milliliters, and there's no fraction. So no units on bottom. That's what that tells me. So I know that I have here 30 milliliters per hour. So I'm going to start with that. I'm going to start with milliliters on top because I need milliliters in my answer, but it says no units on bottom. So I have to get rid of those hours. So I'm going to say times with hours on top. And here it says for 8 hours. So it's 8 hours over 1. Because then my units cancel and I just have that. So I'll have 240 milliliters. So at any time you can pause the video as I'm going through it so that you can work on the problems yourself and then come back to the videos. If you need to. The order is 1/2 normal saline, 1,000 milliliters in an IV at 50 milliliters per hour. If the IV starts at 12 o'clock on Monday, at what time will it finish? Ooh, there's a doozy. So I'm going to start with, I need a time. It says, what time will it finish? I need a time for my answer. So I need it to be in hours and minutes. The rule of thumb here is if it's over 60 minutes, then I need to have it in hours and minutes. But if it's just 60 minutes or under, then you can just write it in minutes. So if I need a time on top, I look here and I see 2 times. I see this time to start with, or I see this time to start with. And then if I look further into it, I'm like, oh, wait, this right here is just telling me what time it starts. I need to know what time it finishes. So later on, I'll need to know what time it started to do calculations to find out when it finished. So the only other option I have in this whole problem is the 50 milliliters per hour. But then I noticed that hour is on top, on bottom, but I need time on top. So I'm going to flip the fraction. I'm going to say 1 hour is 50 milliliters. The reason why I can do that is because I can say that ran for 1 hour and you would know 50 milliliters pumped out. I could say that ran for 50 milliliters. That patient got 50 milliliters of IV injected. And you could say, oh, so it ran for 1 hour. That's a unit fraction because it's interchangeable. So I'm going to start there, 50 milliliters in 1 hour. But then notice I don't need something in the bottom. I just need a top. So I'm going to say times. And I have to get rid of my milliliters. So if I look back up in my problem, notice I don't read the problem. I look to see what I need, and then I look at the problem. And this says that I need 1,000 milliliters of an IV. So I'm going to put that over 1. When my milliliters cancel, I'm left with hours, which is great because that's my time in hours. So I'm going to say 1,000 divided by 50, and it gets 20 hours. So that's a time, but it says what time will it finish? So if it starts at 1,200 hours and 20 hours later, I have to do the calculations. Now, me mathematically, I would do a lot of different things, but you may be able to be like, oh, well, if it starts at 12 hours, that's noon. So the next day at noon, it would be 1,200 hours next day, which would be 24 hours later. But I only need 20 hours later, so I'm going to subtract 4. So this would be 0800 hours the next day. So it would be 8 a.m. That was awesome. Let's see what else we have here. So the prescriber ordered a quarter normal saline, 850 milliliters, and an IV in 8 hours. The label on the box containing the IV set for use in the infusion is shown on the label here. Calculate the flow rate in drops per minute. So this gives me a bunch of information. I'm kind of confused. There's a lot of things. There's a quarter, there's 850, there's 8. And I just look because if I'm following my directions from before, I'm going to go calculate the flow rate in drops per minute. So I'm going to say drops per minute. And when I say drops per minute there, I'm going to go and look for something with drops or something with time. And if I look in the stuff given to me, the only thing I see is 850 milliliters in 8 hours. So that's good because it gives me a time. And there's a time, so I can say cool. So 850 milliliters in 8 hours. But I need to get hours to minutes because none of those match the end results. But I'm going to get hours to minutes. So I have 1 hour is 60 minutes. And I had to put hours on top because that's what I needed to cancel on the bottom. So now when I'm done, I have milliliters per minute, but I need drops per minute. So I'm going to times it again and put drops or milliliters down here. And now it says also, it says the label on the box containing the fusion is shown on the label given. So if I look over here at this label, I'm going to look for some kind of drop factor. And when I look for the drop factor, I see this big here, 10 drops per 1 milliliter. So now I can fill this in with 10 drops for 1 milliliter. Then I can cancel my milliliter with my milliliter, and I can do my calculations. And I can say 850 times 1 times 10 is 5,800. I mean, 8,500. And then 8 times 60 is 480. So if I go 8,500 divided by 480, I get 17.7. But since it's in drops, I cannot put drops as a tenth. I have to make it into whole units because you can't say put 7/10 of a drop somewhere, right? So what you're going to do is you're going to put it into round it to the nearest whole number since we're talking about drops. So it's going to be 18 drops per minute. And that's going to be your answer. If you answer 17.7 drops per minute, it's wrong. So make sure that you know when you talk about drops, it's in whole numbers. Okay. The prescriber orders dextrose 5/0.45% NaCl, sodium chloride, through an IV to infuse at 21 drops per minute. If the drop factor is 20 drops per milliliter, how many milliliters per hour will the patient receive? So I'm going to look at this. You can pause it at any time, remember, and come back when you need to. It says how many milliliters per hour will this patient receive? So I'm going to put milliliters per hour here. And then I'm going to start with something with milliliters or start with hours in the bottom. If I look back up here, I have 21 drops per minute. They have to go together because this per. And then I look here, it says the drop factor is 20 drops per milliliter. So when I look, I'm going to start with the milliliter because the milliliter is on top. So I'm going to say 1 milliliter is with 20 drops. So I've used that. When I look at here, I see milliliters are milliliters, but this does not match this. So I'm going to say times with drops on top. And then the second thing I underline there, I see 21 drops right here. So I'm going to say 21 drops per minute. Which is great because then I can cancel out my drops. But then when I left, I have milliliters, which is good, but I have minutes, and I need hours. It's not minutes. So I'm going to say times with minutes on top. And I know that there are 60 minutes in an hour. So now I can cancel out my minutes. And I'm left with milliliters, which is on top, which is great, and hours, which is on bottom, which is great. If your units don't cancel, then you did it wrong. What? That is awesome. So I'm going to do 21 times 60. I'm going to get 1260. And on bottom, I'm going to get 20. So 1260 divided by 20 is 63. So it's going to be 63 milliliters per hour. I'm going to, okay. An IV of 1,000 milliliters of 5% dextrose and 0.9% NaCl is started at 8 p.m. The flow rate is 38 drops per minute and the drop factor is 10 drops per milliliter. At what time will this infusion finish? So here we have, at what time will this infusion finish? So we need a time. So my answer needs to be in a time. And the only thing that I see up here with time is at 8 p.m. it starts and 38 drops per minute. So the time's going to be in minutes because I have 1 minute for, for 38 drops. Then I need to keep minutes, so I'm going to say times with GTT on top. And the GTT, now I need drops. So I go look at my problem again, and it says the drop factor is 10 drops per milliliter. Oops. So I have 10 drops per milliliter. When I cancel out my drops, I'm left with minutes over milliliters, but that's not cool because I just need a time. So I need to times this with something with milliliters in the top. And here I have 1,000 milliliters. And it doesn't have a linking verb. It has of next to it. So of doesn't have the division part, right? That wasn't one of our words. So it's not a fraction with anything else. So for 1,000 milliliters, and now I'll end with the time. So I'll have 10,000 divided by 38. And I get 263 minutes. But remember, time has to be in hours and minutes. So you have to make that into hours and minutes. So if I do the long way, because I like that better, if I put 60 minutes into 263, then 60 minutes into 263, I'm actually going to do this. 263 minutes. 263. 6 goes into 26 4 times because it's 240. And I have, so this would be 4 hours, 23 minutes later. If you want to do dimension analysis, you would have 263 minutes over 1 times 60 minutes in an hour. And you get 263 divided by 60. It would be 4.38. 33333. Do not round it yet, because this is where people come in mistaken. And you're left with hours. Now you have full 4 hours, which is what we had before, 4 hours. And to get the rest of it, you're going to subtract 4. And in your calculator, you're going to left with 0.38333 hours. So 0.38333 hours. It's still in your calculator. We're going to change it to minutes. So times 60 minutes in an hour. And it'll give you that. So if I take away the 4 and then I divide by 60, then I have, I multiply it by 60. Sorry, multiply it by 60. Multiply it by 60, I have 23 minutes. If you decide to round with this, then round to the nearest hundredth. Don't just do the 10th, because if you did just 0.4 times 60, you'll get 24 minutes. So you do get different answers. So the answer for this one here is 4 hours, 23 minutes. And it matters. 4 hours, 23 minutes. after 8 o'clock, so that's 12 a.m. So it's going to be 0, 0, because it's 12, 23 hours the next day. What? That's awesome. So the order reads 1,000 milliliters of 5% dextrose in an IV over 8 hours. The draw factor is 10 milliliters per hour. After 5 hours, 700 milliliters remain to be infused. How much the flow rate must be adjusted in drops per minute so that the infusion will finish on time. If the facility has a policy that the flow rate adjustments must not exceed 25% of the original rate, it is required the required adjustments within guidelines. I'm actually going to stop the video here and do another video on this because I want to talk about it.